Dear audience, please welcome Mathias Jung on our stage.
Thank you. Thank you that you are having me. So I should talk a little bit about teaching SDR for amateur radio. So let me just. So can you please mute because that is distracting me. So I have to figure out how this works. Okay, there's a lot of latency, so maybe I'm not using it. So let's start first. We have over 100 years of amateur radio applications. And everything started with CW. We had just a talk about this. But it developed pretty fast, and it's kind of an exponential thing, right? And we have now topics like SDR, but new topics on the horizon. We have the Taylor modes, we have digital modes. We grouped ham radio with the internet. We have Hamnet, we have DMR, Whisper, and many more applications. So we have this kind of exponential development of ham radio applications. And so when we look at our exam in Germany, we still have exam questions which are more than 20 years old. And that was the reason why we said, hey, we have to change the exam, we have to change the teaching. And this was the idea how to start with the new Class N that we have introduced. So we have the Class A and Class E, and they are compatible to HAREC and the ERC report. And there's also a recommendation from the CEPT that says, hey, you should also have an entry-level class. We had that back in the 90s in Germany already, but then it was cancelled. And now we have back introduced that. So basically from, early this week, from Monday on, people can take this Class N exam. And we have now a new examination system. So you can just go to Class N, and then later you upgrade to Class E, and then to Class A. And you can also go directly to E or to Class A. Yeah? And this was a project that I was leading basically for almost 4 years now. And such a project requires time. So we started in 2020. There was a kickoff in January, and 2 months later, then we have this small apocalypse, basically. So we went completely online. So we conducted this project basically completely online. So the first thing that we did, we wrote a manifest that describes how we want to teach and also to examine ham radio in Germany. And this we presented to our authorities, and they said, hey, that's cool, let's do that. So thanks very much to BNetzA because they trusted us such that we can do this. Yeah. And also in parallel, we started to develop new training material, and also with respect to this diversity that we have in ham radio. Yeah? So we tried to bring in these new digital topics, and especially also SDR. And we presented, or the new regulation in Germany was presented last year at ham radio. And since then, we were in this transition phase. So they gave us 1 year to prepare, basically, for the new exams. And now, in December, they also published a question pool. And now, we had the first exams also here at ham radio. And so far, I learned everything was pretty successful. So people are able already to learn for this new exam. And our goal is not to wait 20 more years to update this exam again. And therefore, we decided that we will have yearly reviews of the current topics in the exam, and then update this if it's required. Yeah? So this is kind of the context how this has been developed. And I just want to show you a little bit also the contents and how these 3 classes differentiate also. So we have the Class N, which is the entry-level class. And this class should give you an introduction and an overview of ham radio. Very simple calculations and apply simple formulas. So a Class N licensee should know, this is an example just here, that in a diode, current flows only in one direction. This is kind of the level of abstraction. This is an example that I have chosen just to explain how these classes differentiate. So class E, they should have qualitative understanding of relationships, and this is paired with simple calculations and converting of formulas. And with my diet example, they should know now that it's not just only current flows or not. There's a graph basically that describes the behavior of this diet. And then there's class A, and this should be in-depth understanding, but it shouldn't be an engineering degree. And this is very important because every citizen in Germany should be able to get the class A. Yeah, not only if you have studied electrical engineering like I did. Yeah, but for our diet example again, the idea is then that the people understand how this PN junction works, right? So that's the level of abstraction. And we have there some requirements also, because this comes basically from HAREC and from the CEPT recommendations that I showed before. Let's look now on these digital topics. So the HAREC, for example, requires the following topics. The requirements in the syllabus on digital signal processing are rather limited, so we have these two entries there. So they have digital signal processing, which was 20 years ago, how we called that, right? So we should have questions in the exam like sampling, minimum sampling rate, you read it. And also digital signal processing. So this is what is recommended by HAREC, and this is, I think, updated. It was updated last time 2004, so 20 years ago. And it's not talking even about Shannon-Hartley, source coding, channel coding, and all these topics that we already use in our ham radio appliances. Yeah. And this brings me to a very big challenge here. So we want this in-depth understanding, but it shouldn't be an engineering degree. That's the challenge that we had to prepare the question and also the teaching material. So yeah, just show it again with a cartoon. So this is kind of the university level. That's what I learned when I studied electrical engineering. Complex numbers, convolution and Fourier transform and all this stuff. And on the other side, there is ham radio, where we are on a much more abstract and non-math level. And there was only one solution to solve this. The solution was that we use only qualitative understanding and practical understanding. If somebody wants to go deeper in the topic of digital development there or SDRs, then one can do that, right? But it shouldn't be part of the exam, because we don't have complex numbers, for example, in the exam. But it works also very well without it if we show some qualitative examples. I will also give you some examples in some minutes. But we created 100 new questions in this domain of digital topics. And we categorize them in 3 parts, actually. So we have the practical part. Oh, sorry, I forgot to translate this slide, at least this bullet. So this is the practical part, basically. The second topic is digital signals, encoding, and modulation. And then the last part is then digital signal processing. And in this practical part, we talk about, for example, the waterfall. We talk about how to connect your transceiver to your PC. So you can do that with audio, with USB, and all of this. And also the modes, basically. So we talk about modes, but in a very different way. So we don't have exam questions that are asking what is the channel code which is used in FT8 or something like this. Because we think this is kind of nonsense to ask something like this. It's more important to tell the people how the concepts are. So we developed questions which are independent from specific modes. and that's important. So we have questions that ask for the general concept of something, but not on a specific mode. Because if Joe Taylor maybe next year comes up with another fancy thing like FT8, then people will switch, and then our questions are basically for the trash. Yeah. So, but the concepts are always the same. So that was one decision that we made. And as I said before, we have many qualitative questions. Yeah. So that's also important. You don't have to calculate an FFT. You just have to understand that an FFT brings you from time domain to the frequency domain. Yeah? And this is one of these example questions also. Here we ask for the phase shift of an IQ modulator, yeah? For example. So this is also something that we can show very good qualitatively. I will give you an example for that in a minute. Yeah, so the summary of our changes. So almost every question that we had, we have reworked, but this is not bad because we improved them. We have new aids for the exam, so band plans, call sign plan, and something like this. The new class N is very easy, that's also easy. We have new questions about remote operation, they are also rather easy. And we removed tubes from the exam. Yeah, sorry for that. But we think this is kind of a niche topic. We like tubes. We also like CW, yeah. But we have to show also the new things of ham radio. So we have also to transmit a new image of ham radio, and we should start with that in the exam, right? And the most important challenge here was that we have now this more than 100 new questions in the field of SDR. And as we say in Germany, this is kind of Neuland, so uncharted territory or waters, for many hams in Germany, yeah, because they didn't learn that in the past. So what we did here, we did a weekly teaching on our online platform, treff.drc.de, and we did that for 4 months. Actually. So that was kind of an interaction between us and our teachers, and we did this kind of inverted classroom concept. So they were reading this material beforehand, and then we discussed it. And this is how we trained our trainers, basically. Yeah? And that worked pretty well. So many trainers are now actually quite comfortable to teach these new topics, because they are actually not so complicated as they look if you don't use the math and the formulas, if you don't go this way. Yeah, yeah, so some examples, just to show you some questions. They are in German now. I was not able to translate them. But here we have the concept basically of continuous time, discrete time, and so on. But also here some questions. Yeah, so what should be the rate to sample, and we also, of course, explain this very, very easily. Yeah, and also here, for example, with the Shannon Hartley, we used also some tricks. So if you know that at 0 dB, this is your SNR, then basically the bandwidth and the data rate is the same, right? So the questions are also not so difficult. So if you know this, then this is easy to solve. Yeah. Yeah. So for example, here, have to see it. This is about concrete modes, but it's not about the details how they work. Yeah. But it's just that they learn to categorize the different modes. We even put M17 there. So we really are convinced that these kind of open source approaches are the right way to go, yeah. Also in ham radio. And there are some other things, yeah, for analog to digital conversion. For example, here, so A is always the correct answer, by the way, on these slides. Here we want to transport the idea of, okay, if you have not so many bits, then of course you cannot sample in a fine granular way, right? So you have to use 12 bits to get a curve basically which is shaped like answer A on the right side, and if you don't use enough bits, then you get this thing with a lot of high frequencies in it. Yeah. Another question, so how does a digital transceiver look like? And that was interesting because we had to invent new block symbols for this. Because we Googled, we did a lot of literature research, and there were no symbols for the channel codes and source coding and also the mapper. So we just invented them, and I think they are quite good. So you see, you put in redundancy, you remove redundancy, and then you make a mapping, basically, to the IQ symbols, right? So who can give me the answer? So which part is actually missing there? Is it A, B, C, or D? On the previous slide, it was always A, but it is not here, so that's what I can say. It's either B, C, or D. Thomas? B, correct. Yeah, as a small gift, you get a 50 ohm.de 50 ohm dummy load. Thank you. Okay, yeah, going back, I want to show you some examples. So this is the dummy load. It's a cool thing, and now we are basically back to the last part, so how we actually train people. So, or how do we want to shape the training in the future? So this is a typical class. I think even Christoph, you are on this picture. So that was in Kaiserslautern, a ham radio class where I did the organization. And at the first evening, many people come, so we put a lot of posters in the university, and many people came to this place. And then we show how diverse amateur radio is, and we create excitement for ham radio. And after the first class, everybody is excited, and they want to be a ham. And then the week after, we start with the concept of electrical engineering, with the basics. And then 1 week later, the room looks like this. And this is not how we should do teaching in the future. No, this picture was before Corona, yeah, that I showed before. But why don't we start teaching with something like this? Yeah, not going so much deep into the electrical engineering, but we have to cover the topics, but not in the beginning. So we turned this around, basically. So our old teaching was from resistor to radio, and our new teaching concept follows the method from the fascination of ham radio down to the resistor. So we cover all the topics, but we reorder. And you see that also in the course plan. So we start with call sign, spelling, alphabet, operations, and stuff like this, and then we can go on the band with the trainees. And we don't put this boring stuff at the beginning, we put it in the end, and if people reached already up to level 12 here, they also go the last mile, right? So you can learn for class N in 14 days, basically. It's possible. And for that, we created this website, 50ohm.de, where you can learn that. We focus there on education, training, and the people can interact. We will have also exchange with instructors online, exam simulation and stuff like this. And I gave yesterday another talk here at Ham Radio more about the details. I summarized this basically now. So we have interactive material. We have also YouTube videos and stuff like this. But I just want to show you a little bit some interactive material. We also wrote a book, we have an app and all this stuff, but let's focus here on the SDR topics. So maybe let's go first on this one. No, I have to leave the presentation mode. No, it doesn't work. Now. So then let's go there. So this is live now in the web. You can also have a look there. So I go to start. Now I go to class N, for example. And also there we have already these digital topics for them. But let's go to modulation, just that you get an idea. For example, here, and I hope that works with this computer now, Probably not. So there is a speech signal in our book. It's constant, but we are on web, so why not just say here, enable microphone? So can I use this one? Okay, then it should work. And then people can watch their own voice in the browser. So my dream is that we have a fully virtual SDR in the browser and they can make an QSO with an artificial intelligence. That's my dream. And I try to reach that, so that we can really do this training online, yeah, completely in the browser. And we have all the things in the browser API already. So this WebKit has everything that you need for signal processing, which is cool. So why don't do it? So that's one example. So since I cannot click these links, it's a little bit difficult. So maybe it works like this. For example, IQ. How to teach that? The most interesting thing is probably to put it in kind of an applet here, where you can basically say then, okay, I have here some amplitude for I and some amplitude for Q, and then you see that you can change the amplitude and the phase of the outcoming signal. And this helps a lot, and also the constellation diagram, this helps a lot to understand this, even though you don't have much math for this. And that's the way how we tackle this, basically. There's also another thing, for example, for Fourier transformation, we do something like this. So this is not yet integrated, I have to do that, where you can see then both views. Yeah? So you see the time domain, you see the frequency domain, but now you can do things also interactively. Yeah? So you can change, for example, here the amplitude and stuff like this. Yeah? So we want to teach of all of these concepts in a very qualitative way by using also these interactive applets. Yeah, and that's basically the end of my talk. I put also the links there. I think you will get the slides, and then you can have a sneak peek into these topics. So this is the teaching material. And at the end, I just want to say thanks to my team. So more than 75 people worked with us together to get this new teaching platform running. And if you have recommendations how we could improve, just send us an email. And then we will also take ideas. And thank you very much, and thanks for your attention. Do you have questions? Any questions? Yes?
Do you detect any negativity from people who've learned the traditional way about amateur radio? Use the microphone, please. Do you detect any negativity from people who've learned the traditional kind of teaching with tube amplifiers and things like that? Or is everybody being very embracing of the need to teach the modern approach?
No, there's actually no negative feedback. Of course, in the beginning it was, but then if people, the problem was we were, I think, almost 3 years in stealth mode, because our authority said, okay, you don't have to, you cannot talk about it. So they scanned our slides, and I discussed with them what I can talk about. And there were, of course, a lot of rumors what will come. But now if people saw, basically, that it's not that hard, then they were rather positive. Yeah? So I think people understood that we have to go one step further and don't teach things which are 20 years old. So it makes sense, right? So, and people said, okay, that's cool, and I will also do this. So actually not so much negative feedback. Yeah.
Okay, no, that's good, thank you.
You're welcome. Yes?
I have a question. You said that the moment.
But online, they also.
I give you the microphone.
Yeah.
Thank you. You said that the question pool is under review and might be changed after a couple of years. Will this be announced early because you need at least 1 year or 1.5 year preparation for the newcomers and not to get into this change.
Yeah, exactly. So this was a hard change. If you don't do anything for 20 years, then you have a hard change. But if you just change 1 or 2 questions per year, then everything is not so difficult. And the cool thing is, all the stuff that we have developed is in a database. So we have traceability. If I change an exam question, I know exactly which paragraph for the teaching material I have to rewrite. And I know also which minute in our teaching video we have to change. So I think we are here pretty flexible, and I think we will just report kind of a version history, and then people will, or the instructors will also see what are the new topics, and they can very quickly adapt. That's our goal, instead of waiting another 20 years, yeah, because that would be the death for ham radio in Germany.
And this goes in line with the BNetzA?
To change that, yeah,
Yes.
of course, they are on board, yeah.
Okay.
So I hope, it might be that they say, oh, no, we don't want anymore. That would be bad. Therefore, I hope they don't do that, yeah. But that's that was the idea together with them,
Very
to do
good
this
idea.
regularly, at least once in a year, to check if there is a need for a change. And if it is, then we will do it, yeah.
Very good idea.
We have a problem with digitization in Germany, and hopefully this is one step forward. And it's a big step.
Yeah. And therefore, I'm really happy that our authorities committed also to
Yeah,
our approach. Yeah.
And the Ministry of Transport is also the Ministry of Digitization. So you can see this is responsible for ham radio, and they make an experience, and hopefully they continue the experiments.
Yeah. Okay.
Any further questions? This is not the case at the moment. Matthias, I thank you very much.
Yeah, thanks, Mike.
Big applause for Matthias and the team.